I'm going to just demonstrate that the accelerometer works because the connectivity tends to drop off when I start streaming video through the Wi-Fi. So if we pitch down, it goes negative. If we pitch up, it gets positive. If we roll to the right, we get a larger negative roll. Roll to the left, we get a positive one. And this updates at every 1/10 of a second. The latitude, the LLA going through the GPS, that is updating every second. So that just shows that our data feeds are at different rates for the different systems. Now for the demonstration flight, on the right we have the recording of the data we're getting from the drone, and on the left is the video of the drone flying. And for the Wi-Fi connection, there is a significant delay, especially when trying to process the data from the camera. And so sometimes you'll see the drone move and there'll be a rather significant delay. Taking off, there is quite a delay. I decided to combine the orientation data with the GPS data because in my mind it made sense to just have all that displayed from in one place. You'll see I'll roll hard to the right and none to the left, and that roll orientation will go about 30 degrees negative and then 30 degrees positive. And unfortunately, the refresh doesn't display the pitch forward or back or the yaw very well. You get a couple in there. Okay, so going over the code on the left side of the screen, we're going to have the code running on the Raspberry Pi, and on the right is what gets loaded onto the Arduino. And so on the left side is the service. I decided to go with a Python script to run to capture this orientation data, mainly because it's the load of this process is just taking one file, getting some serial data, and putting it in a new file. And so since this is only going to run every 3/4 of a second or so, it's there's a lot of time where it doesn't have to process, and speed is essentially not a huge factor. So I decided to take the simple route and go with a Python script. Here is similar to Project 7. I have a script that I use to push the code where it needs to go in the system, the directory, and make sure that the services get reloaded. It's the Excel daemon service. Now, the actual Python script to grab the data is we're just looking at the USB port, and we're using the serial library to make sure that we have a good connection. Sometimes it switches over to ACM2. I don't know why, but I have this check in there just in case it makes that switch. And then once we have a connection, we will pull from the LLA file, which in Project 7, I had the live stream. And you've seen in the demonstration, I had both the GPS data and the orientation in one spot. And so this is how we're doing it. We take that file and then take the latitude, longitude, altitude, and we open our new file. And as long as we can actually open it, we take our roll, pitch, yaw from that connection and then print it all into the new file and close the file and then wait. And so this will run as its own service on the Raspberry Pi. And so sending that orientation data is what's going on the right side of the screen. So this Arduino file is using the free RTOS library, which allows us to use tasks and queues and semaphores. And I do happen to use all three of those because to do some debugging, I had to write to serial. I have two tasks. And so in order to debug both of those tasks, I had to have both of them write to serial. And so you need a semaphore so that they don't step on each other while they're trying to write. And that happened a lot. So we have our sensor, and we define our tasks. We define the semaphores and the queue so that we can send our orientation data from one task out to the other task, which is the transmit task. And so we define our tasks with our sizes, the priority. I have the transmit task as a lower priority than the gathering the sensor data. This was without loss of generality. I just picked one to be a higher priority since they're both, even though this could run as a round robin approach where just read, send, since we're using the free RTOS, I'm just making sure that the whatever reading gets sent off is the most recent one. Okay, so here's a reference to look at for queues. Very helpful. And so now I have it, the size of the queue is going to be the same size as our IMU data structure, which I created just because it was a nice way of being able to unpack and pack in this, like, instead of like a triple in Python where we have roll pitch yaw and then we can parse it. I just made this struct so that we set them all and then send them off as one big unit inside our queue here. So we have our current IMU read, and it's going to be of the roll pitch yaw that we set here. And since we have to wait a little bit to get our sensor data, we can say go get it, but we have to wait a couple milliseconds. So that's why we have this delay here. And then we set it now that we have the data, and then we send it on its way through the queue. And then for stability, we delay 10 milliseconds. So while this is getting sensor data from our orientation sensor, the task or the transmit task is going to actually send the serial data. And so I left in the semaphore here to give and take the semaphore because that's kind of a remnant of debugging the read IMU task. But in case there are other parts of the Arduino that are using serial data, I think it's safe to leave it in here just in case. Okay, so this way it gets sent with the roll, the pitch, the yaw, and then with a comma separating it. And then we are just parsing it by splitting the line, knowing that the first one is going to be roll, second one's pitch, and the third one's yaw. And then at that point, we delay until the next time we transmit. One thing you might notice is that our queue size is 1, so essentially it's running as a mailbox. Otherwise, sending things onto the queue would just have old data since the queue would be full and I would have to overwrite. Now there is a timer kind of that you can set, but instead I just have it where I have the size of 1 to minimize the size, and then we just overwrite that 1. Whatever's in the mailbox is going to be the most recent, and that's what we send every 500 milliseconds.